Today we're going to look at how to simplify, multiply, and divide fractions that involve factoring. So my first step if I'm multiplying is to think about when I multiply numbers. And when I multiply numbers, we multiply straight across. So if I have a over b times c over d, I get ac over bd. So I have these two really big fractions, but the main thing I want to do is factor the tops and bottoms of both these fractions. So I'm going to start with my first numerator right here. So I notice that it has a GCF of 4, so I'm going to factor out 4, which leaves me with x plus 4. Now I'm going to go to the bottom. The bottom is a difference of two squares. Put your parentheses, one with a plus, then a subtraction, yes you must, square root of the first, square root of the last. Then we're going to multiply. And my next two ones have 3 terms, so this is where we're going to use the x. So what two numbers multiply to 12 and add to negative 7? That's going to be negative 3 and negative 4. I'll probably be really nice and give you only ones that you need to use the x shortcut and not ones that you would have to do the box as well. I'm nice like that. So looking at the bottom one, we want the two numbers that multiply to 15 and add to negative 8, which is negative 3 and negative 5. My last step is to reduce. So just like 5 over 5 equals 1 or negative 7 over negative 7 equals 1, something like x plus 4 and x plus 4 is going to reduce to 1. So once I've factored it, I can start reducing things. So I have x plus 4, then I have an x minus 3, and an x minus 4, x minus 4. So all I'm left with for my final answer in the top is 4. Let me go to actually pen. 4. And in the bottom is x minus 5. So that whole hot mess simplifies down to 4 over x minus 5. So we have another multiplication problem. So the main thing I'm doing is factor, factor, factor. So my top of my first fraction is what multiplies to 12 and adds to 7. Well, that's going to be 4 and 3. So my first numerator is x plus 4, x plus 3. Now let's put it over the denominator. And another 3-term one, so what two numbers multiply to 16 and add to 8? That is 4 and 4. Got ahead of myself there. 4 and 4. So x plus 4, x plus 4. Let's go to the next one. I have what two numbers multiply to 4 and adds to 5, which is going to be 4 and 1. So x plus 4, x plus 1. And then that's going to be all over. This is another difference of squares. So if you got two terms perfect squares, subtraction in the middle, let's go from there. Put your parentheses, one with a plus, then a subtraction, yes you must. Square root of the first, wiki, square root of the last, wiki. Keep them in order and you're done fast. Okay, so let's go through and see where I have some common factors. I just start on the top of the first fraction. So I have an x plus 4 in the top. I do also have an x plus 4 in the bottom. I can't cross off both of the x plus 4s right now. Do I have an x plus 3 in the top and the bottom? Nope, so that's going to stay. How about another x plus 4? Yes. How about x plus 1? Yes. So my final answer in this one is going to be x plus 3 over x minus 1. So we have just another similar type problem. What two numbers multiply to negative 12 and add to negative 4? We have negative 6 and -2. Obviously, things that would really help in these problems is your factoring skills and making sure also your multiplication skills and everything are good to go, because it's really going to hold you up. Okay, then our bottom one is what two numbers multiply to 12 and add to 8, and that's going to be 2 and 6. Also watching your signs with these. Okay, what two numbers multiply to 36 and add to 12? 6 and 6. And then we have another difference of squares. If you got two terms, perfect squares, subtraction them all, let's go from there. Put your parentheses one with the plus, then a subtraction, yes you must. Square root of the first, square root of the last. Keep them in order and you're done fast. That was a horrible 6. There we go. And now we look for any common factors in the numerator and denominator. So do I have an x minus 6 in the top and bottom? Yes, x minus 6, way down here, x minus 6. How about x plus 2? Yep. How about another x plus 6? Yes. And another one. Yes. Oh my goodness, everything reduces. Okay, go back to our first thing we were talking about, fractions. If I have 4 over 4, what does 4 over 4 reduce to? 1. So this whole thing is going to actually reduce to just 1. Yes, we did all that work to get 1. The next thing after multiplying is going to be what you think, which is dividing. So, with dividing, what you want to do is keep your first fraction. Then we're going to change from division to multiplication, and we're going to flip our second fraction. So this is just multiplying by the reciprocal. Okay, dividing something is the same as multiplying by the reciprocal. Like dividing by 2 is the same as multiplying by a half. So my first task in these is to flip my second fraction. So I'm going to have x squared minus 25 over x squared plus 10x plus 25 times x squared plus 7x plus 10 over x squared plus 4x plus 4. Okay, if you do a problem and you don't get a lot of stuff canceling, I would check and make sure that you did not forget to flip your fraction if you're dividing. Okay, but we leave our first one. So factoring the top, that's a difference of squares. Hopefully you're getting better at noticing those. So x plus 5, x minus 5 over. We have 3 terms, so we're going to use the x. What two numbers multiply to 25 and add to 10? It's 5 and 5. Times what two numbers multiply to 10 and add to 7? 5 times 2. And the last one, I'll move over here. What two numbers multiply to 4 and add to 4? That's 2 and 2. So x plus 2, x plus 2. So now we go and look and see what I can reduce. So do I have an x plus 5 in the top and the bottom? Yep. Oops, I meant to change that to highlighter. X plus 5, x plus 5. Do I have an x minus 5 in the top and bottom? Nope. How about an x plus 5? Yep. How about an x plus 2? Yes. So I'm left with, overall, x minus 5 over x plus 2. So when I'm dividing, the first thing to do is to flip my second fraction. So x squared minus 5x plus 6 over x squared plus 6x plus 9 times x squared minus 9 over x squared plus x minus 6. So what two things multiply to 6? Positive 6 and add to negative 5. That's negative 2 and negative 3. That's a horrible 3. So x minus 2, x minus 3. On the bottom, what two things multiply to 9 and add to 6? 3 and 3. So x plus 3, x plus 3. And then we have a difference of squares, so that's x plus 3, x minus 3. And then last one's an x. What multiplies to negative 6 and adds to positive 1 is going to be 3 minus 2. Now let's look and see what we have the same. Do I have an x minus 2 in the top and bottom? Yes. Do I have an x minus 3 in the top and bottom? No. Do I have an x plus 3 in the top and bottom? Yes. So this one I'm going to be left with a little bit more, and we don't need to multiply it all back out. You can just leave it as x minus 3. Now I can be lazy. It's x minus 3 times x minus 3, so shortcut would be x minus 3 squared. And then on the bottom I have x plus 3 times x plus 3, so once again let's shortcut it a little bit. X plus 3 squared. Last one, we're dividing, so the first step is to keep your first fraction, change to multiplication, and multiply by the reciprocal, so flip your second fraction. Hopefully you're getting good at seeing these difference of squares because they come up a whole lot. All right, so what two numbers multiply to negative 4 and add to negative 3? That would be 1 and negative 4. So x plus 1, x minus 4. What two numbers multiply to 8 and add to negative 6? That would be negative 4, negative 2. Times difference of squares, x plus 2, x minus 2. And last one is another x. What multiplies to negative 6 and adds to 1? That's going to be 3 and negative 2. Factoring, factoring, factoring. Super important this unit. All right. X plus 1. Do I have an x plus 1 in the top and bottom? Nope. How about x minus 4? Yep. How about an x plus 2? Nope. How about an x minus 2? Yes. Okay, so once again, we have some more left over. That's okay. You do not need to multiply this out. So x plus 1 times x plus 2 all over x plus 3 and x minus 2.